A crime has taken place in the Turks and Caicos Islands. Animal behavior has been disrupted and habitats have been modified. Who could be behind this?
Our team at the Center for Marine Resource Studies in South Caicos have been challenged to investigate this crime, the impact of recreational snorkeling on animal behavior.
After some investigation, we have a prime suspect: ecotourism. Responsible, sustainable, and educated interactions with wildlife and natural areas that leave low to no impact.
Ecotourism was seemingly innocent at first. It encouraged tourists to interact responsibly with the environment, learn about local species, and spreads awareness about environmental concerns.
But there is a dark side. Regulations about ecotourism are often hard to enforce. Animal behavior can be negatively impacted, and pristine ecosystems may become disrupted.
To get to the bottom of this crime, we did some of our own investigations.
To complete this investigation, the following methods were conducted.
A group of private investigators went snorkeling at Jerry Camp on East Bay to see how a common and seemingly non-invasive ecotourism activity like snorkeling affects marine megafauna.
But we needed more eyes on the scene, so with the help of a drone flown by UCN, an aerial view of the snorkelers and surrounding environment was recorded, allowing us to better capture any animal encounters.
In the past, research on human-wildlife interactions performed in the marine environment utilized more invasive and expensive methods, but the use of the drone allows us to monitor large areas very quickly, at low cost, with fairly low effort, and most importantly, in a non-invasive way.
While the drone flew overhead, the snorkelers swam at a relaxed pace for 10 to 15 minutes, with a scale bar holder setting the pace for the group. A colored signal card was used to indicate the presence of any megafauna, like turtles, sharks, or rays. This process was repeated a total of 3 times at each site.
After returning to the center, any animal encounters captured on the drone footage were uploaded onto ImageJ, an image processing program for scientific image analysis, to perform some calculations. The distance between the closest snorkeler and the encountered animal prior to swimming away was recorded, also known as the flight-initiated distance, as well as the angle between the snorkeler and the path taken by the animal while fleeing, also known as the angle of approach. Lastly, ImageJ was used to identify the size of the animal that was encountered by the snorkelers.
Through this investigation, we have found that on average, marine megafauna encountered by snorkelers fled at a distance of 14.621 meters, or around 48 feet. Additionally, the average angle of approach was 92.604 degrees. The average size of animals encountered was 0.561 meters, or just under 2 feet. When comparing the average flight initiation distance between the two snorkel locations, Jerry Camp and East Bay, it can be seen that there is a larger distance observed at Jerry Camp compared to that of East Bay, with the non-overlapping error bars indicating statistical significance. This is possibly a result of the fact that East Bay is a public beach and the animals may be more habituated to human activity from both locals and tourists. When comparing the flight initiation distance of turtles from that of sharks and rays, it can be seen that there is very little difference and no statistical significance in the data. This could be an indication of the fact that all megafauna exhibit similar flight responses in reaction to human activity.
We have found that even respectful snorkelers tend to still be avoided by many marine creatures. In fact, the footage captured by the drone indicates that many of the animals swam away before the snorkelers had even noticed them, indicating that despite keeping our distance from marine megafauna, we still might be disrupting their behavior.
This investigation consisted of a relatively small sample size, meaning that we cannot determine any true statistical significance from our data. However, valuable information was still gained, giving us an idea of what needs to change in order to keep ecotourism from committing this crime again.
Although good intentions may be in mind, those engaging in ecotourism must act with extreme care for the natural world around them. Marine megafauna, like all animals, deserve to live in a world free from human-related risks and stressors.
Since there are no universal set of rules for ecotourism, it's difficult to enforce guidelines. Considering that ecotourism is advertised as responsible and sustainable interaction with wildlife, it's easy for many tourists to believe that their actions are not negatively affecting the surrounding environment, despite realistically causing harm. This has the potential to lead to bad practices by tourists, like getting too close to or touching wildlife, not following the leave no trace principle, or feeding wild animals, also known as provisioning.
These actions take a major toll on the ecosystem and could result in ecosystem degradation, like endangering of species, the destruction of habitats, and the depletion of many resources. The resulting effects do not only harm the environment, but also put unnecessary and harmful pressure on locals who rely on fisheries as a major food source and to make a living.
The practice of responsible ecotourism isn't emphasized enough, and the lack of education on this matter is the true criminal.
Managing ecotourism is becoming increasingly important and relevant as the tourist industry grows in South Caicos.
As more people come to experience the natural beauty of this island, let's take action to preserve the natural ecosystem home to so many native species. By making sure ecotourism stays out of trouble, tourists can enjoy South Caicos and its marine inhabitants without causing harm.
When researchers, the government, and tourism industries work together, ecotourism can be what it's supposed to be: responsible, sustainable, and educated interactions with wildlife in natural areas that leave low to no impact.